So right now we have the graph of y equals 1 over x plotted. And so let's look at when we have 1 divided by x to different odd powers. So let's start with to the third power, and we'll also look at 1 over x to the fifth power. And you can see the different colors here. So red will be 1 over x cubed, and black will be 1 over x to the fifth. And if we plot these, you can see that they roughly look the same, but slightly different. And for now, just so that we can compare the blue and the red curves, let's turn the black curve off. So I'll just go to y equals and then turn off its equal sign. And what you can see comparing 1 over x to 1 over x to the third power is that they're very similar, but as x starts to approach 0, so let's go trace it and we'll be on our red curve. Right now it's at 0. Notice it's undefined. And let's start at 1. And notice that as we go to the left, that the y values increase much faster than the y values of the blue curve. So it's essentially shooting off to infinity at a much faster rate. So notice for this particular x value, its y value is roughly about 4,500. But if we look at the blue curve for that same x value, the y value is significantly smaller. So that's the main difference between the two, is how quickly it will shoot off to infinity or how quickly it will approach 0. So right now we're on the blue, so if we go to the red curve, notice it's a much smaller y value for that same x value, and it'll approach 0 much faster as x increases. So notice for this x value, if we go to the blue curve, the y value is much greater. So you can think of the red curve as approaching infinity much faster as the x values approach 0, or it approaches 0 much faster as the x values increase. And you could see the same thing on the negative half. If we look at -1 and we follow the blue curve, you can see the y values are approaching negative infinity, but on the red curve for the same x values, the y values are much closer to that minus infinity. And again, the curve is going to approach 0 much quicker as x gets more and more negative. So let's now put in that black curve, and we'll see that as the power of x increases for these odd powers, that this pattern is even more dramatic. So now it's a bit harder to see, but we can still trace along these. So let's start at 1, and now we'll go to the black curve, and we can compare it to the red curve. And since this is a higher power of x, it increases towards infinity much faster. So we'll scroll down to our red curve, and you can see that's at 35.9 or so for that particular x value. And on the black curve, it's at 391. But again, compared to that blue curve, the blue curve is only at 3.3. So as x gets closer to 0, it goes to infinity much faster. And you would see a very similar thing happen on the negative side. It's just going to approach negative infinity much faster. And so we could keep looking at this pattern as you go, but the higher the power of x, the faster that it approaches infinity as x gets smaller and smaller, and the faster that it approaches 0 as x gets larger and larger. But the main point is that for y equals 1 over x to any odd power is that they roughly will look the same as y equals 1 over x, just with some slight differences on how quickly it will approach infinity or how quickly it will approach 0. And with that in mind, let's notice the same thing basically happens for comparing 1 over x squared to 1 over x to any even power. So let's go back to our graphing calculator and we can clear everything out. So let's start by putting in 1 divided by x squared and looking at that compared to 1 over x to the fourth power. Graphing both of these, you can see that they do indeed look very similar. The only major difference is that when we put in values closer and closer to 0, now on either side, that the red curve, 1 over x to the fourth, because it is a higher power of x, is going to approach infinity much faster. So let's look at values close to 0, like let's say 0.5. For the blue curve, 1 over x squared, it's at 4 for the y value, but for the red curve, if we use that same x value, the y value is at 16. And this becomes more dramatic the smaller the x value we put in. If we put in 0.1, it's at 10,000. But on the blue curve, if we put in 0.1, it's only at 100. And likewise, as you put in larger and larger x values, the y values will be much closer to 0 on the 1 over x to the fourth graph. So this is 1 over x squared, and if we go to the other graph here and plug in the same x value, you can see it's a much, much smaller y value. And we can also see that this pattern will continue as you put in higher and higher powers of x in this denominator here. So 1 over x to the sixth still looks very similar, but again, it's just going to approach infinity much faster for values near 0, and for either very large values or very negative values, it's going to approach 0 much faster. So in conclusion, with all of this information, the main point is that when you have y equals 1 over x to some odd power, whether it be 1, 3, 5, 7, or so on, it will look very similar to this with some slight differences depending on how high the power is. And when you have 1 over x to some even power, it's going to look very similar to this curve here with, again, just some slight differences as the exponent is increased.